Welcome again to another episode of the Sustainability Podcast. Today, I'm thrilled to be joined by Rolf Bienert, Managing Director of the OpenADR Alliance. Welcome, Rolf. How are you today?
Thank you, Jim. It's great to be here. I'm doing really well. The sun is out here where I am, so that's always a positive, right? And the solar is powering on the roof.
That's great. Now, we've known each other for quite a while, but for many of our audience, they may not know your organization, the OpenADR Alliance, or how it came to be, or how you came to become the managing director. So can you give us a little background about who was Rolf Bienert and how did your path navigate you towards leading the OpenADR Alliance?
Yeah, it's actually probably kind of an interesting sort of full circle that I did there. As you can hear, I'm German, born back in Germany, and then I lived 21 years in California. And in fact, about 3 years ago, I moved back to Europe. So I'm now back in Europe, in Portugal actually. So did a bit of a round trip there, but still, of course, very involved in the US stuff. But since you asked where I'm coming from, I'm actually originally a telecom person. And I think many of us in the standards world, right, are coming more from, technology, controls, and so on, and not necessarily from the utility side of things. So my first kind of, touch point with utility stuff was early on when I moved to the United States. I went there for a test house to do ISDN testing, DSL testing, these kind of testing services back in the 2000s. And very quickly we started the test house in Zigbee, Wi-Fi, Bluetooth, these kind of industry standards. And in fact, just before that, I was part of a team that worked on some of the first Bluetooth testing stuff, but only briefly, really, in the late 90s. Anyhow, so I was in the Silicon Valley, northeast edge of the Silicon Valley, and all of a sudden, 2000, 2001, we had rolling blackouts. Coming from Germany, and I never really experienced a longer blackout. Maybe there was like here and there, maybe a little blip, but that's it, right? And all of a sudden we had an hour-long, sort of semi-scheduled blackout, right? And we all had no idea what's going on, of course, at the time. But later on, then we heard about Enron and all these stories, right? Where it was simply a mismanagement of available capacity, right? So the way I understand it, and I could be wrong, it's a long time ago, is that some available reserves were sold multiple times, right? And then when we had a hot summer day and multiple states needed those reserves, all of a sudden it was, we only have this once, so not everybody can have it at the same time, and the utility had no way of really counteracting that. So they had to literally turn off cities. And I'm saying this because this is kind of important lead into what OpenADR does, right? Anyhow, I worked for a few more years at the test house, getting the testing services started for a number of these industry standards. And I was then eventually asked in 2005 to join a management consulting firm. And their business was to actually manage these industry alliances. That's when I got a good, look behind the scenes of how this all works. And then in 2010, late 2010, the OpenADR Alliance was started, and I knew a number of the people that were on the board, so they approached me and asked me to initially become the technical lead of the group. So, but back maybe briefly then to OpenADR and those power outages, all right? Because that's when everything started. The California Energy Commission, after these problems, said, well, we cannot have that, of course. We cannot just turn off things. So we need to have a mechanism between the utility and the customer side to convey signals about available resources or prices or whatever it is. And at that time, it was just basically resource management, shaping of the peak, right? If you have these afternoon peaks of consumption that simply, threaten to poke through the production curve, we would try and flatten that up so it stays under the production curve. So OpenADR was conceived then as the protocol to communicate these type of informational and motivational messages to the customer side.
Very good. And that started in 2010.
Yes, so the Alliance started then. So before that already, as I mentioned, after the energy crisis, everything kind of kicked into gear. And the Energy Commission put out a grant, so a number of companies and organizations participated and created the OpenADR 1.0, a very California-specific standard, which has been used in California since the mid-2000s, basically. But then you might recall with the economic problems we were facing in 2008-9 and that area, the government put a lot of means and money forward to really accelerate the smart grid efforts, right? And that's where a lot more requirements came to us, and basically a group from NIST and the SGIP, the Smart Grid Interoperability Panel, some listeners may remember that, put together this framework for demand response. And out of that, then the requirements and all the functions for OpenADR 2.0 came out. And that's when the Alliance was started, because there was a need for testing, certification, branding, and so on and so forth.
So Rolf, let's talk about, for those that are uninitiated into this, before there was standards and interoperability between different sources and loads and different generators, how was that data communicated?
Yeah, so demand response, or in a sense, managing the demand side, if you will, is not a new concept, right? If we look at it, I think in the US, we have seen that done in particular with larger consumers, factories, things like that since, 20, 30, or maybe even longer years. But of course, the communication to those customers it was appropriate to the times, right? It started with simple phone calls, right, where a utility operator would literally call a small number of larger consumers and beg them basically, hey, could you today shift the usage and things like that, right? Of course, this is not scalable. But then later on, we had faxes, right? Fax machines came out. So, okay, it was a mass fax. Later on, pager messages. But as you already noticed, right, this was all very much a one-way, here I throw you a piece of information and we hope for the best kind of system. And then I think what probably came next to some extent, likely driven by aggregators, is that they had proprietary interfaces. So an aggregator would maybe gather certain resources, and maybe for some of the listeners that are not so familiar with that, so we call a resource any kind of power consumer or producer on the customer side. So it could be anything from a pool pump, because a pool pump may be consuming 2 kilowatt, 1.5 kilowatt or something like that. If we turn that off, it basically becomes this 1.5 kilowatt resource, right? It runs, it loads the grid, but if it stops, it gives that power back, if you will, It's a bit of a strange concept to wrap your mind around. But essentially, so turning off consumers that are permanently running will create a dip in the usage profile, right? And with that, give the utility something to play with. Same on the other end of the scale, you have a solar system, right? Or a battery, right? And you start discharging that or using that. So obviously much more of kind of an active participant here, not just a passive decoupling, but rather, okay, we increase the capacity that we push into the grid. So any of this is a resource here, really. So what the aggregators did was essentially they go out and try to recruit these resources, right? So they might go to, I don't know, a conference center, right? Or a school or a small, medium business park, office buildings, They would probably rarely go to private households, right? This is just for them, that would be way too much work. And we can talk about that in a second. But so they would go out to those, low hanging fruit, as you say, right? Where, let's say, an office building or a conference center has already some automation built in, but they're of course not connected to the grid, right? So they go there and they look and they say, okay, if we add here a little interface point, like a gateway to our control center, we can ask you to, for instance, change the air conditioning, change the lighting, ventilation, you name it, right? Anything that's there. Or, for instance, a big target for a while was refrigeration units, like food chains and things like that with huge refrigeration units. If they knew that in the afternoon power was either short or expensive, depends on what the programs are, they could start pre-cooling these refrigerators, bring the temperature down a few degrees, right? And then, okay, at let's say 2 p.m., sun is up, it's hot outside, we turn off the compressors and let the refrigerators or freezers slowly come back to the actual temperature, and with that basically have a couple of hours, 2 or 3 hours window, right, where they don't use energy. So these aggregators would gather these resources, but they are typically then connected with some proprietary interface, right, which is all good and fine, unless, of course, the aggregator goes out of business or, or there's some changes and things like that, right? Then it becomes problematic.
Right. So the aggregators had a standardized way of doing this, but it wasn't open nor was it published. They had their internal processes.
Exactly. They had their internal processes, and they would also, I neglected to mention that, so I was talking about the downstream to the resources, right? But also to the utilities, they would basically communicate with some proprietary system or even phone calls still or things like that, because it's a different animal here, right? You have an aggregator that maybe has I don't know the numbers, let's just say a terawatt, right? Might be a bit high, but still. So that's an easy thing for the utility to literally call, right? Or send a message. So, again, if you, however, communicate with thousands of resources, solar inverters, batteries, pool pumps, thermostats, things like that, then that doesn't work anymore, right? Then you need a standardized system to be able to onboard all of these.
So Rolf, thank you for that background. I think that's a great illustration for our listeners, and for myself as well. So can you move on to, what the list of objects in OpenADR 1.0 or 2.0? I know that it's a substantial list. When I looked at it even 10 years ago, and I can imagine it's only grown given all of the distributed resources we have today. So can you walk us through particularly what was 1.0, what was 2.0, what are perhaps the most important objects in the standard, or feel free to respond as to what's important there.
Yeah, absolutely. Happy to do that. And in fact, we even have now a 3.0 version of the standard, so I can quickly shed light on that as well. So, as I mentioned, OpenADR 1.0 was a very California-focused standard with very simple signaling. I wouldn't even necessarily call it a standard per se. Yes, it was written down, but it was really only created by one company with a number of partners in California. So yes, it was a standard there. It was published through Lawrence Berkeley National Lab, but there was no other compliance system or anything there. It was then a company called Acuacom, later Honeywell, that just sort of managed all these partners. But anyhow, the idea here was really to only flatten those peaks, as I mentioned, right? So the signals in there were very simple. You would, and that's still the same to this day, you would send what we call an event. And that is one of these services or objects, as you say. So that's really the most important structure that we have, is this event. And you can picture that very similar to a calendar invitation. So if you look at, for instance, our discussion here today, right? So, we send out a calendar invite, hopefully compatible, right? If it's from Outlook to Outlook or, iMac, things like that. There are some compatibility issues. So here, hopefully we're talking about interoperable messages. But anyhow, it's like a calendar notice. It has a start time and a run time, or start time and an end time. So let's just use an example, similar to what we said before. So the utility knows today between, or let's say in the early afternoon, it's going to be really, really hot outside. Very typical California use case, of course. It will be really, really hot outside, right? So we know that all the air conditionings will be running full power and so on and so forth. So they want to reduce the load at that time. So what they would say is they would send an event that starts at 2 p.m. ends, let's call it 4 p.m. Right? So you have a 2-hour window, and in there they would send they could send different intervals. At the minimum, one interval, so the full 2 hours. And let's say they think, okay, we might need a little bit of power back, nothing major, right? So the very original system in OpenADR 1.0 would just send sort of a level 1. So really in OpenADR 1.0, everything was limited to just a few numbers. 1, 2, 3, 4. So whereas, you have basically, or in fact it was, if we talk to engineers here, I can say that the levels were actually 0, 1, 2, 3. So 4 different levels, but starting at 0. So 0 often would be compared to normal operation, right? A fallback number. Number 1 would be seen as a moderate shed. Okay, so we need some power back, please, do something. In thermostats, it might mean, increase the temperature temporarily 1 or 2 degrees or something like that, right? Then number 2, high shed. So, give us maybe a little more, whatever you can. And then again, this is often already preset in some functions, again, maybe a few more degrees on the air conditioning. Maybe now we turn off the pool pump or whatever it is. And then number 3 typically was something like an emergency. Okay, so we really have, a state, grid emergency, save as much as you can, right? So these were sort of these conventions that we saw in 1.0. And later in 2.0, we added a lot of different signals there. So pricing, specific pricing, discrete numbers. You could set everything. You could set even offsets, temperature offsets for thermostats, even though I mentioned it earlier already in OpenADR, we don't really like to control customer equipment directly. We rather give them, information messages. So the customer through pre-settings and things like that can determine what they want to do. But anyhow, setbacks for thermostats, direct energy requests, maybe capacity, very important, for instance, for EV charging networks these days, right? We might give a capacity message to a certain area, right? Where the operator of chargers would know, okay, I have at this point only X megawatts, X kilowatts available for my chargers, right? So this could go then to the control system of a charging network, and they can make then the decisions, okay, who can keep charging, who do we throttle back, maybe from 3 to level 1, or, whatever it is that they want to do. Or maybe somebody's already at 80%, we turn them off, and so on and so forth. So a lot of options. So as you can see, the idea is still the same. So that event, that calendar invitation here is still there, but just with way more functionalities built in. And then there's of course also feedback, where the resources can send back information elements. Yes, I'm cycling, I can cycle off, or if they have sub-metering, they might even send back current energy consumption and what they can do and things like that. So all depends on the programs. But to be honest, typically most of these programs, even today, have been fairly straightforward. Either they give you a price or sort of a request for some energy increases or decreases.
You mentioned that the version 3.0 is underway. So what enhancements? 2.0 I think came out a few years ago, maybe a decade ago even.
Actually, looking at the date here, it's 11 years ago that we published 2.0b. Kind of crazy to think about that, but thanks for bringing me back to the topic here. Yes, 3.0 is really the standard is done. We are just finalizing now the certification program for it. And to explain a little better why we did it, I have to quickly step back to 2.0b. So 2.0, as I mentioned, came out of this collective or the collection of ideas, I should basically say, that we had during that smart grid interoperability panel work, and it was all very closely connected to the people that work on the IEC standards, the IEC data models, and so on. And this is of course all XML code. So 2.0b was basically an XML schema and communicated in a SOAP exchange model. So there would be basically a SOAP-based message over the internet communicated to the client device from the server, which we call the virtual top node or VTN, and the client for us is the virtual end node or VEN. And so that SOAP message was being either pushed down or pulled from the server, and then the client responded and it went back and forth. And this still works perfectly fine today. But honestly, it's not really what most developers do these days, right? You have the phone apps and everything is web services these days. So since several years, people were nagging on us, hey, can you do a JSON version instead of XML, for instance? Because, all the young programmers, they might not even really do much with XML these days, so they want a JSON. And we were sort of saying, yeah, it's a good idea, but we were reluctant to say we transpose 2.0b into a JSON schema. There's actually even translators, so it would have been easy, but how do we manage interoperability, right? So all of a sudden we have 2 times the same standard, but it cannot really communicate, right? Because it's a different message. And then there were also a number of other comments that we collected over the years. So eventually we said, okay, we need to start looking at the future and think about maybe something like a 2.0C or new version, right? Maybe we swing that then around to JSON and so on. And then it in the discussions, it really kind of came out that a lot of people were really interested in having this a real RESTful API, right? So because everything today is RESTful, right? With a common and modern security mechanism, OpenADR 2.0b uses a perfectly valid security scheme with TLS 1.2 security certificates and stuff like that. But anything you do these days on the internet, right? This is all RESTful services using like Auth2 authentication, right? So even if you connect one app to another and it asks you to really pull something from your LinkedIn into the other subscription, right? So these are all like REST implementations, and they use OAuth2. There's different spelling, different pronunciations for that. But anyways, so we said, okay, if we already do a new version, we do the full step, right? So we kept the ideas. Again, the event is still there, right? The feedback is still there. All of that is still there. We threw out a few things that nobody ever used, and we added some more specific signal types. For instance, for specific grid interconnect management of inverters. In some areas, this is a concern, even though I haven't really seen it used much. But how to control the grid, the grid facing parameters of an inverter, volt-var curves and things like that, to keep the power quality stable. Australia asked us to add signal types for dynamic operating envelopes. Kind of an interesting concept they use in Australia to kind of limit what a household can export and consume. So they're kind of limiting these two ends of the scale, so to speak, because they are concerned. Interesting segue here. They are concerned that this delta can get very, very big. Let's say a house has 10 kilowatts of solar, which is not uncommon in Australia due to incentives and so on. And then at the same time, they have, let's say, a 24 kilowatt charger, right? So at the best of times, they might export up to 10 kilowatts. And then when the sun is down and the car is plugged in, they might draw basically negative 24 kilowatts. So there's a huge envelope between these two, right? Which gave them gray hair over there. So they wanted to kind of adjust these envelopes, right? So they're trying to send these signals to
That's interesting, Rolf. One of my questions as you were speaking is this energy transition of all these distributed resources, of vehicles that are mobile energy storage that might charge here but discharge there, wind, photovoltaic. How has that changed or added to the standard? And I think you talked a little bit about it there.
Yeah, absolutely. And I mean, it's really actually a very important component here, right? Because one doesn't work without the other, really. I mean, as we just said, right? Australia is not necessarily the only country where this is happening, right? We're seeing in Germany also, big solar, rooftop solar installation numbers, and we see it everywhere in the US and in other countries as well. And really, somewhere in that loop needs to be this connection between the customer equipment and the utility, so that we can balance this out, right? And OpenADR actually, kind of without knowing it, really happens to be right there, right? Because we came originally, as I mentioned, just from curtailment, right? As we said, flattening that curve. That was the main idea. But of course, we can up and down regulate. For us, it makes no difference whether we tell the resource to, okay, project more power or take more power, right? So it's for us exactly the same.
Well, for me, it might be a very simple analogy, but I view it almost as if we're going from a world that was a master-slave scenario with a generator at one end and then I counted electrons at the other to get my bill, to now really a peer-to-peer network. And granted, there's some huge peers on the network, but those peers are getting smaller and then over time are being removed. So it will be a plethora of smaller peers that need to have some kind of electron traffic management system, let's call it.
You're hitting really like also the main challenge here. And that challenge has multiple facets, Number one is that, as you just mentioned, the utilities are very much used to onboarding the customer, giving them a cable, selling them energy, taking their money, period, right? And we still see that, and I'm German, so I don't want to talk down on the Germans, but I noticed that a lot in for instance, some German utilities that they don't want to talk to the customer, So as long as they can avoid that, they're happy, right? So much easier to regulate the consumption by adjusting the overall price, right? If you tell the customer your energy gets 50% more expensive, they'll save some, or maybe not charge their car. Of course, in the long run, that's not gonna work, right? And I think we will see more and more also other states in the US noticing this, right? Because we have a lot of the states, especially like Midwest and so on, where energy traditionally is very inexpensive due to low taxes and other regulation or lack thereof. And there is still this challenge that there is very little incentive to get the customer to participate, right? If you pay a very, very low rate, 24/7, what's your incentive to shift, your charging or any other stuff, right? So that's one thing there to, first of all, get the utility to really embrace that idea, what you just mentioned, right? That you're working with a peer, right? That peer can help you, right? Not only by installing solar or something like that, but also, as we say, by simply turning off consumption, right? And we see it with a few new consumers that are coming online. EV charging we already mentioned, but also things like heat pumps, right? We're seeing more heat pumps coming where they replace standard air conditioning, no problems, actually probably less power. But Washington State, Oregon, they have seen this transition from gas water heaters to heat pump water heaters, right? And all of a sudden, you have a completely new energy, or electricity, I should say, consumer there that you didn't have before, right? So Washington State and Oregon and slowly also California has been struggling to bring out some requirements, for instance, to make the more modern heat pump water heaters also communicating to the grid. So there's another standard downstream from OpenADR, EcoPort, an implementation of CTA 2045, which would be a module that just goes onto the water heater, for instance, so that.
Oh, where are we in the effort to have? I think much of this would be driven by real-time energy pricing at even the smallest consumers. And I'll just give an analogy that, and I thought about this yesterday. I'm in South Florida. I have a sprinkler. I put in a new sprinkler controller to water my lawn. Don't use it that often. But this new one, of course, was Wi-Fi connected, and it goes out to some weather app,
Nice.
and if it finds out if it's raining in my neighborhood and doesn't run if it rained in the last 24 hours. I would love my air conditioner if the rate went sky high at 3 p.m., okay, give me 3 minutes of downtime or half an hour. But we seem to be, in much of the developed world, a long way away from that.
You're hitting on something that's a little bit of a pet peeve of mine. And even though I'm not in the IoT industry and probably know way less than I should about all the technology, I am always kind of bashing on them a little bit, right? We've been talking about IoT for I don't know how long, right? Is it 10 years?
Right.
Is it 20 years? I think since early Zigbee times, right? Or sort of the idea there. And, I always like to say cynically, I guess, that, if I have 6 apps on my phone to control 6 systems in my house, that's not IoT, right? That's an expensive remote control, right? And that's exactly as you say. You might have the controller of your sprinkler system on here, and I have the controller I have my inverter, my solar inverter on here, right? And I have my heat pumps on here, but currently I still have no app that connects them all. Right? Where I say, okay, the temperature in my house is going up. I have solar running and I don't need the solar power anywhere else. So turn on the AC. Do that automatically, right? If the sun goes down and I have less solar, turn it off, right? Things like that. But Jim, the interesting thing is we do start to see these kind of energy management platforms. Just, I think they are not as well known by many consumers, I think. There is platforms like, and I don't want to, do any commercials here per se, but, for instance, Energy Hub, Rainforest, up in Canada and a few others, right, that specifically do that, right? They built a, I believe, cloud-based platform which they then create partnerships with all the individual home automation people, right? So maybe with with your sprinkler system, right? With my air conditioning system, and everything, right? So that over time they build all these APIs to these individual apps, right? So that when the consumer really logs onto that platform, they see their house, right? And they just say what they want the house to do, right? Be energy efficient.
Certainly.
I need my car charged 75% minimum by 7:30 in the morning, right? Here's my sprinkler system. Here's everything. Optimize it for me. And I don't really want to hear about it. Send me a message once a week that tells me how much I saved this week by doing that. Right.
Rolf, I think we are. We're looking. One of my questions is what do we see for the future? And I think we're already going down that road.
Yeah.
Quite a few years ago, for example, traffic signals in the U.S. have, 8 or 10. Well, there's probably now 20 different standards of terminal devices. They each have their own application and their own API. They were standalone, but I've lost track of the effort, so I can't speak to its recency. But even 5 or 7, 10 years ago, there were efforts to make a traffic signal. Now they are Linux, and they run all those applications together using an integrated data repository. So the industrial world can call that a data fabric or a digital backbone, But I think the root of all of this, of all of what we're discussing here is we need one trusted source of truth, and then the applications that ride on it might be different based on our persona. Because you've got solar inverters, I've got a sprinkler. I think that's really it in a nutshell.
Yeah. I don't quite see that yet, right? I mean,
It's early.
Of course, where we saw an effort on that is with CSA, right? What is it called? Consumer Standards Association or Alliance, where the Zigbee Alliance basically transformed into this new organization, including then Zigbee and Zigbee Transport with Matter, right, and other building automation. So at least we saw a little bit of a consolidation there. So that was a good idea, or is, I should say, a good idea. And in fact, we have a member in the UK that is looking at also building, for instance, a bridge between OpenADR, in particular 3.0, because it's web services, to a Matter gateway. So that, for instance, a home automation system could easily get, let's say, price signals, dynamic prices, as you mentioned, into the building, right? And then that home automation system could then manage it. The refrigerator might know the price, right? And again, I think it's really important for any of the listeners here that is in the business of making these consumer facing applications, energy is not Twitter, right? Or, whatever we call it these days, or Facebook or Instagram or Snapchat or something. Right. It's boring, right? The customer doesn't really want to know about it. The customer just wants to know it works, right? And it gives them benefits. And I think that's a challenge for all these manufacturers there to make that work.
So let me bring it back to some of that dry, boring engineering talk. So OpenADR 2.0 or 3.0 is an API, a data standard. Talk to us a little bit about, when I think of interoperability, I often think of the 7-layer OSI model. And in a layman's term, for those of you who don't know it, there are 7 layers. The bottom one, for me, is, does the connector match? So is it an Ethernet plug or an RJ45 or USB 2.0 or something like that? At the highest level 7, it's the application layer, where, you need to speak exactly the same language. And just because, French, English, and Spanish use the same character sets mostly, doesn't mean you could talk to each other, because the applications aren't the same. So, Rolf, where does OpenADR 2.0 reside in that interoperability stack?
Yeah, and I think I wonder, is that dating us when we talk about the 7-layer model?
I've got a little gray hair.
Yeah, totally. So probably, one of those things that we still learned in the university, right? But anyways, I think these days, I think the layers are kind of washing into each other a little bit, but it is really in the application, on the application side, because we don't necessarily care, what communication medium you use. We just use the internet. So roughly speaking, we run over IP, and we don't care if that IP is over power line even, or, wireless, Wi-Fi, cellular, cable, DSL, fiber, you name it. In fact, interestingly, in the UK, in the demonstration project that they are building right now, they're even running it now over the smart meter network, the AMI network, because they can also send basically IP packages. They're often just a little hacked up. And but we are sitting on top of IP. So if we take all these lower layers out, physical, right, and networking and so on, so application layer and maybe a little bit, I'm not even sure exactly where you would put security here, right? If we put that a little bit in the networking side or so, right? So we do define obviously this REST API. So we are not only defining the messages that are being sent, but we are defining the REST API. So I guess arguably it kind of is application with the hooks
Got
in
it,
the next layer
for security. In fact, Rolf, I'm not sure you're aware of this, but back in 2012, 2013, I was contracted to do a lot of standards work for the U.S. Department of Transportation in the NTCIP Intelligent Transportation Systems standards. And one of them that I was most intimately involved with was the 1213 Electrical and Lighting Management Systems, which started with simply turning streetlights on and off and some ground fault issues. But that standard was walked over to the Department of Energy, embraced as one of the initial draft standards to be included in the SGIP Smart Grid series of standards. And as a result of that, funding came through to the Department of Transportation to include EV charging and automated demand response and connected vehicle support. The EV charging portion, the team there, which I was part of, looked at the EV charging standard from Europe, OCPP 2.0. At the time, it wasn't mature enough. It was a bit ambiguous. So we had to back up and map to and use the Modbus objects that were actually in the hardware. For the vehicle to grid piece, the 802.11p and connected vehicles, not autonomous vehicles, work very nicely. And I'm saving the best for last, because when we looked around for any kind of automated demand response standards, we used OpenADR 2.0, took the major objects and mapped them to SNMP OIDs. Because the U.S. DOT's NTCIP effort, the National Transportation ITS Communications Protocol, which is in fact used worldwide, Brazil, India, throughout the Caribbean, started a very long time ago and is still SNMP. So the major objects at the time we mapped so that you could tunnel it legally on a piece of critical infrastructure, that private fiber backbone that's on a road, and then open it up back at the traffic management center and send it on to your utility in a format that the utility would recognize.
Interesting.
Yep.
And crazy, right? That you think it's 12 years ago, right? So.
Yeah. It took a while to get published, because as soon as that work was finishing, we had a change in U.S. administration, who was not so enamored by standards and more of the free market. But it did get published when the administration changed again.
Funny how that goes, right?
Yeah. So, Rolf, this has been a fascinating almost an hour. What haven't we touched upon? What else would you like? What do you see for the future? Good question. I think really, one of the big topics that we have been discussing, even a little bit behind half closed doors, if you will, is that there's still more need of harmonization, as you already said, with building automation, integrating everything, right? But
But sort of, I think that's again for the IoT people, we would want to shake them awake and, really take that into account. But there's a lot of people working on that. But where we also see a need for some additional harmonization is now with the whole electric vehicle system. And I specifically try to keep this vague here a little bit. What is that system, right? But I'm talking about the car, the charger, the utility, and the owner, integrating this all together. We have good standards. You mentioned OCPP, right, for the charger. OpenADR. We have, IEEE 2030.5 for inverter management, things like that. So we have good standards, but we don't really have yet a quantifiable, or I should say a qualifiable framework for all of these things working together, right? So that the customer can take advantage of that. Knowing if I buy a vehicle XYZ, I know I can, get a better tariff from my utility maybe if they manage my charging. What's the interaction, right? At this point, buying an electric vehicle is still a novelty, I guess, for people, right? They don't really think about, what do I have to do with my utility to charge it? What implications are there? But sooner rather than later, it will become not buying an EV, right? But just buying a car.
I agree with you across the continuum. First off, myself and my two neighbors cannot all charge our EVs at the same time when we're all on the same transformer.
Yep.
Who's going to broker that? Am I going to have a microgrid where I broker my needs against my neighbors, or is the utility going to do something and manage that, or some third party?
Right.
And that's at one end of the continuum. On the other end of the continuum is, I'm a school district and I'd like to charge my 300 buses. And what substation do I need? Or is the approval process so long in terms of years that now I want to build a PV and battery storage network to charge my buses? I think we're getting faced with questions that we just never had before. Do we make the school buses take-home vehicles for the bus drivers?
Right.
Charge at home.
And I think, and we are getting a little philosophical now, but you already basically said it, that with all of this, there needs to be a bit of a change of mentality, right? I mean, we know that, right? We realize that it's easy. You hop in the car in the morning to drive a few hundred miles away and you realize, my gas is low, no problem. I go to the gas station, fill it up, right? And then I go, right? No big deal. But everybody's kind of used to that. But okay, now you have to maybe think about that the day before, right? So, I need to go further tomorrow than just to work. So I need to have my battery fully charged. So maybe I need to go in my app, right, and tap I need a full charge button, right, to leave, and a charger on the way or there or whatever it is, right? So there's a certain change there. Whether this is good or bad, is always a good question, right? Any change is good and bad, right? So you have to change your behavior, but there might be other advantages.
Rolf, this has been an enjoyable hour. Thank you for educating myself and our audience. Lastly, if anyone in our audience would like to reach out and contact you, can you share some contact information?
Absolutely. My email address is very simple. It's rolf@openadr.org. So that's ROLF @openadr.org. or, just go to our website, openadr.org. And there's a contact form, or info@openadr.org. If you forget my first name, all of these come to me one way or the other. But of course, I'm also on LinkedIn. If you search for Rolf Bienert, and that's probably the most common place I hang out here and there. So that would be the easiest through these two means.
Well, Rolf, thank you for joining us today.
Thank you for having me, Jim.
Okay. Once again, our guest today has been Rolf Bienert of the OpenADR Alliance. He's the managing director over there. And we hope to see all of you again on the next episode of the Sustainability Podcast. Thank you for joining us today.